So this is one of the slides that I had. I can't claim it's mine. This is from Jeff Leek. He's a data scientist at Johns Hopkins University. But this is a really important sequence in the data science process. These are the steps that you'd have for a data science exercise. So step one, you'd start with defining the question. So it always starts with a question. What are you trying to do? What are you trying to answer? And then after that, that question leads to you defining the ideal data set, which may or may not exist, but if you could get your hands on, you would ideally like to have to answer the question. But then what you actually have will be a subset or be different to this ideal data set. So you need to determine what data you can access. And you obtain the data then by writing scripts or writing SQL queries or whatever you can do to pull in the raw data from different sources. And so then cleaning the data is merging and binding, fixing it to a format which is suitable for exploratory analysis, which is your next part, and then ultimately statistical modeling. But your exploratory data analysis is graphing, understanding trends, understanding what's going on, and it really informs your statistical prediction, your modeling component of the exercise, which comes next. And so it's a really important overlooked part, is to explore the data, plot it, and then build a model. And then after you build a model, you can then start to interpret the results of the model and do they make sense. And this is more seeing if it sort of feels right in terms of your intuition. And then after that, it's challenging the results, so determining what could have gone wrong, what is erroneous assumptions you're making, maybe there's a problem with the population, just thinking about the ways it could have gone wrong. And then finally, there's a report where you sort of boil down your results. You're not going to include every graph and every bit of work that you've done, just the key points and the key things to be able to communicate the analysis to someone else. And then the last step, but also an overlooked step, is creating reproducible code. So reproducible research is a big thing in the last couple of years, and it is about having the having the inputs and having the outputs in a way that it's very easy for someone to replicate what you've done. So that is the raw data, and the code, and the descriptions and the graphs are often put together in R, that's with knitr, or with Python, that's with notebooks. And so the idea is that someone who's new to the work can take your work, run the analysis, and then check it out to make sure that what you're doing is sensible. And that's it. That's a very important thing in the data science process from Jeff Leek at Johns Hopkins University.